Let's take a look at this problem. Let's say 4 people have a race. Let's look at the possibilities of how they could place. So once a person has been listed in a place, you can't use that person again. Because of course, once you win, you cannot take 2 places. For example, if you win first place, you can't win second place also. So, all 4 of them are possible to win first. So there are 4 possibilities to take the first place. Let's list down those places. So of course we have the first place, the second place, the third place, and the fourth place. So there are still 4 possible winners because there are 4 people in the race rather. So there are 4 possible people that would come first. And let's say it's our blue guy here that comes first rather. So it's there. Now, based on the fundamental principle of counting that we had in the previous video, I'm going to write it down, the fundamental principle of counting, we would have to multiply this one to the number of possible people for second place. And now, we only have 3 people left. And let us say that it is our red guy that got second place. I'll place him here. Then, for the third place, there are only 2 possible options. I'm going to have 2. And let's say our purple guy got the third place. And obviously, there's just now 1 possible option for our fourth place, and let's say it's our green guy. So the arrangement of blue, red, purple, and green is just one of the possible arrangements of winning this race. And how many arrangements will we have? That would be 4 times 3 times 2 times 1, which would be there will be 24 ways wherein the race can be won. Or there are 24 ways to arrange our 4 people in our race. So, if you're going to think about it, if we are going to arrange objects, people, no repetition because of certain cases of the situation, by the fundamental principle of counting, we keep on subtracting. Because as you can see, from 4, it became 3, then it became 2, then it became 1. So, what if there are 7 objects to arrange? So if we would have 7 objects, let me change color here. If there will be 7 objects to arrange, and the objects should not repeat 1, 2, 3, 4, 5, 6, 7, then of course out of all of them there are 7 options to be placed first. Since the first one is placed, we only have 6 options left to be placed in the second, 5 in the third, 4 in the fourth, and so on. And by the fundamental principle of counting, once we multiply this, we are going to get 5,040 arrangements for the 7 objects. More so if we're going to have 10. If we are going to have 10 objects to arrange and they should not be repeating, then we would have 10, 9, 8, 7, 6, that should be 5. There you go, that should be 5, 4, 3, 2, and 1. And that will actually lead us to 36,288,000 arrangements. And if we're going to generalize that, if we have n objects to arrange, that means we first take n, multiply it to n minus 1, then we multiply it to n minus 2, then to n minus 3, because as you can see, we keep on subtracting and subtracting until such time we reach times 3, times 2, times 1. And that number, when we arrange them, when we arrange objects without repetition, is called a permutation. So a permutation is an ordered arrangement of items or elements. So we say that the number of n permutations taken n at a time is denoted by npn. Sometimes it is also denoted as p. Oops, sorry, it's not that visible. Let me use a different ink. P and n like this, or sometimes it's like this because this is the ones that calculators would have. So the number of permutations of a set of n objects given, and we take n of those, all of the objects is given by this definition that the permutation of n taken n at a time, that's how we read this symbol, would be n times n minus 1 times n minus 2 times n minus 3 until times 3 times 2 times 1. And that is because of the fundamental principle of counting. So for example, if we are asked in how many ways can we arrange 6 books on a shelf, so that would be the permutation of 6 taken 6, or the permutation of 6 taken 6. 6 are written as subscripts here, which will be equal to 6 times 5 times 4 times 3 times 2 times 1, which would be equal to 720 ways of arranging our books on a shelf. If we're going to arrange a total of 7 students, then we take the permutation of 7 taken 7 at a time, which can be also written like this. And this would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And this would be equal to 5,040 ways to arrange 7 students in a line. By the looks of it, it's actually quite cumbersome and quite inefficient to write that long of a multiplication expression. However, there is a way for us to be able to write this more efficiently. And these are examples of how we can arrange objects without repetition, and we call it permutation.